For someone who is curious about AI but has, say, zero research background, what's their realistic path to joining your team at Microsoft Research?
You don't have to have a long list of publications behind you, so it's not just about knowing a specific language or framework. And I think AI is starting to abstract away a lot of syntax and boilerplate. So what we really need now are...
What are the ideas somebody maybe potentially work on today that can have a huge potential maybe in next 5 to 6 years?
I think the industry is perhaps maybe 5 or 6 years behind in terms of AI use and adoption. So I think there is a huge opportunity.
Awesome. First of all, thank you, Bonnie, for doing this and making out time for this. So I want to just quickly start with a question. I've been reading a lot about Microsoft Research and also like in general AI research, because that's one of the core part of what we teach. So we have a 6-month long program and the boot camp. You went from PhD in quantum chemistry to leading AI research that could now potentially cure cancer, discover new medicine, solve climate change. That's quite a journey. How did it happen, and how did you started your career?
That's a great question. I think I've always been drawn to very complex problems, and I've always been drawn to science. Of course, both of my parents are scientists as well. And so that's what brought me to quantum chemistry in the beginning. But I had always had an interest in pharmaceuticals and drug discovery and development. And so I knew I wanted to go in that direction. It was probably towards the end of my PhD where I started to become more interested in data science and machine learning. And there were a lot of transferable skills between quantum chemistry, computational chemistry, and data science. So that led me to spend most of my career in pharma R&D, running data science and machine learning teams. And then eventually I ended up at Microsoft because they were building this wonderful AI for science team that matched very well with my skills and my background in drug discovery and in quantum chemistry. So that's how I ended up here.
I think this is a very inspiring journey also. For someone who is curious about AI but has, say, zero research background, what's their realistic path to joining your team at Microsoft Research? And another part of this question is, what skills or mindset do you look for when you consider someone as part of your team or when you're hiring?
Yeah, so I think we definitely need more engineers in science and in AI for science in particular. So it's not just about people with research backgrounds. We need builders who can take an idea, reason through it, and actually make it real. So you don't have to have a long list of publications behind you, but you do need to be curious, rigorous, and be able to learn very fast. And I think, also the nature of engineering is changing. So it's not just about knowing a specific language or framework. And I think AI is starting to abstract away a lot of syntax and boilerplate. So what we really need now are people who understand how systems work in physics, chemistry, biology, and who can also collaborate across different disciplines.
So say somebody who is already working at pharma, maybe in the traditional pharma, and now they want to transition into an AI-driven drug discovery because you had a very stellar career there, I think. So how should somebody prepare for that?
Okay, so I think AI for drug discovery is fundamentally going to be multidisciplinary. So we do need domain experts that come from traditional pharma, so people who understand biology, chemistry, the clinical workflows, things like that, and they need to work very closely with those machine learning engineers. So the science behind it still matters, the traditional pharma process still matters, and helps us understand how AI can change the scale and the speed at which we can test hypotheses. So I think if you're already in pharma, your experience is incredibly valuable, and probably the best place to start is by learning how your domain knowledge and your experience connects with the data. So how do we represent molecules, assay readouts, protein structures, things like that, and then getting familiar with the basics of ML. So I don't think that you have to become a model developer, but you should understand how models work, where they're going to fail, and then how to frame the problem correctly. I think also adoption is a big part of the journey too. So AI will augment the scientist, and the people that will have the biggest impact are those who can bridge the two worlds. They can understand the science deeply, and they also know how to work with AI to accelerate discovery.
So just to summarize the entire thing, and also maybe like to put a structure on what exactly you just mentioned. So if somebody has, say, 8 to 10 hours per week, and they want to go into the AI research, now coming from, say, a traditional pharma background, or maybe coming from the technical background, what is a step-by-step roadmap for them should look like? Maybe if you can basically touch upon that, so that will also help a lot of our viewers and students to like prepare and look for a path.
Okay, I would say start out with learning fundamentals. So maybe you learn some Python, learn machine learning and fundamentals. Choose your domain. So if your background's in biology or chemistry, start with that and probably try out doing a project, right? So you could do something like molecule property prediction. You could then reproduce a research paper, a known research paper, even one of the ones that we're doing at Microsoft Research. And then I think sort of the latter end of that would be contributing to open source and sharing your work, or even applying for internships. So I think just having consistent, focused effort is the best way to break into the field.
You just mentioned about like the research which you are doing at the Microsoft. So what's the most mind-blowing breakthrough your team has achieved that people outside of science might not be aware about?
That's a good question. So we actually recently just published a paper on a DFT functional called Scala. So DFT is density functional theory. This is actually the subject that I did my PhD in. And one interesting part of that is that there's a particular part of the functional that's been missing for centuries. So this is a century-old problem that scientists have been trying to solve. So we were able to replace a core component of that with a neural network, and we're able to reach chemical accuracy of that. So it's kind of like replacing the engine of a Ferrari and making it faster and more fuel efficient while still being able to drive it exactly the same. And this has huge implications for our ability to understand molecules and find new molecules for medicines, for energy solutions, and for materials too.
I think I would definitely love to read more about this. I think I was following about your research on BioMU, right? I'm not sure if I'm pronouncing it right. So can you touch upon more on that, like, and how this is also linked to new molecule discovery or the drug discovery? Yeah.
Definitely. BioEMU is super exciting. It's short for biomolecular emulator. So this is a foundation model that's trained on biological sequences and structures, so particularly proteins. So it can essentially predict the movements, the dynamic movements of a protein. And so that can help scientists understand biology at scale and accelerate things like protein engineering, target discovery for drug discovery, and things like that. So if you remember when DeepMind came out with AlphaFold, that was a huge breakthrough, century-old challenge where we could predict the structure of a protein. Now that has huge implications for drug discovery in medicine. But of course, proteins are not static. Proteins are dynamic, they move. And if we can understand the movement and the behavior of that protein, we can design better medicines for patients that need them. And so this takes the next step. It helps us understand the dynamic movements of those proteins.
So the difference between AlphaFold and BioMU, if I'm understanding correct, is the learning for the movement of these protein structures. And can you also explain that how this is gonna help in the new drug discovery? And basically, what's the difference? Because, for example, today I'm somebody who has, like, say, no research background, and I want to like learn about all these new research is coming out from the Microsoft lab. So yeah, how does this affect me as maybe an individual, maybe an engineer? So yeah, maybe like I think two parts of this question. First, like understanding the difference between AlphaFold and BioMU, and then how it basically affects like a normal person.
Yeah, so AlphaFold predicts the folded structure of the protein. which is incredibly important. And in the past, it's, there's been different techniques that would have taken days, months, hours, years in order to actually find those structures. So it accelerates and scales our ability to predict those protein structures. What BioEmu does is it understands how that protein behaves, how it moves, and how it moves determines the function of that protein. And if we understand the function of that protein, we can design better medicines for that. Because, of course, medicines are really looking at how do I design a molecule or another protein, perhaps, that can impact some biology in the human or the bacteria. And that includes either revving some sort of protein up or shutting one down.
Thanks for explaining that in a brief manner. I just want to switch gears to climate change, because I think that is also something which you are currently working on. I read about the project Aurora and how it's helping. So do you want to maybe quickly give a brief about what is Project Aurora and how is creating impact for the society?
Yeah, so Aurora is a foundation model that our team trained for weather and climate. So it learns directly from global weather data, and it predicts patterns with high accuracy and greater speed than traditional physics-based simulations. And so that has huge implications for things like disaster response, farming, and climate resilience. So very exciting and could make a huge impact on the world.
So one question, because again, I am coming from the applied AI background. So what we do at 100x is we teach about the application of all the AI research which is coming out, and see if we can find a business use case or maybe product use case and build on top of it. Where does all this research fits into? So for example, can I start using Project Aurora or maybe say BioEmu as an applied AI engineer and use this to maybe help my pharma companies in India to help them find maybe new protein structures and identify that. So is that something possible, or which stage are we in right now?
Yeah, absolutely. So what we work on in MSR is still classified as research, so it's not yet commercially available as a product, but we do open source and publish most of our work. So you can find the papers, you can find the code, you can find the weights using on Hugging Face, and so we encourage people to go and try them out. We also have Azure AI Foundry, which is a catalog of all the AI models that we've built, and people can go there and access most of our models there too, including BioEmu and Aurora.
So are there any particular applications which you are looking at, or maybe your team or the community is building on top of these models? Anything we could maybe discuss?
Well, I think right now that the biggest thing is about validation and understanding how well our models work. Because like I said, these are research models. The next step is to test them out in the real world. So we are looking for partners who can go and use BioEmu in drug discovery applications. We have another model called MatterGen that's been released. That's a generative AI model for materials design. We would love to partner with people to go in and test them in the real world. So the materials that come out of, say, MatterGen, can we go and synthesize them and learn more about and then refine the models as we build them?
Can you talk about more about the MatterGen, because I think that's also the another major research which is coming out of your lab.
Yeah, no problem. So as I said, MatterGen is a generative model for materials. So essentially, it's a diffusion model, so similar to things like DALL-E or Sora from OpenAI. But in this case, you give it a target property for a material, so something like conductivity. And it can generate candidate materials that meet that specification. And we're using that to test things like how do we use that to accelerate battery development, green catalysts, or things like next generation materials, or even sustainable materials too.
I think we also work very closely with diffusion models. I think so we teach stable diffusion and flux in basically our education program. So for example, if somebody is already working with these diffusion models, I'm assuming the you can say the underlying architecture is gonna be same, and we can use it to now build more practical applications into like different use cases. So can you also give some ideas maybe for engineers who are already good with diffusion models? What are the use cases they can potentially work on using, say, Matrogen?
So as I said, most things are open source, so you're welcome to go in and see what we've built there, and it will be similar to other diffusion models that you've seen in the past, but very specific to materials design. So we work, as I said, multidisciplinary, so we work closely with material science experts and engineers and ML people. So I think anyone could go in and use it to look and see what materials could be generated. So as I said, give it a prompt, explore different properties of materials you might want to see, and then that will generate possible candidates that you could go then explore in a lab.
Thanks for that. It was like on the last note for questions, this is about the emerging areas in AI for science, because that's where you have the domain expertise and you've been like working. I think it's been how long since you've been working in AI for science, if I can ask that?
So, yeah, good question. I joined Microsoft Research 3 years ago, and I had about 10 years of experience in pharmaceuticals before I joined here.
Oh, that's amazing. So what are the emerging areas you are now observing in AI for science, and the things which are you personally more excited about?
I think personally I'm excited about things like autonomous labs. So having AI agents that generate hypotheses, they design the experiments, they analyze the data, and then run the next iteration, all with sort of minimal human input. So I think that's sort of the next generation of very exciting things that will come to things like drug discovery and to materials discovery.
Can you talk about AI agents a little bit more? Because I think this is one of the most hot topic right now. And also, I've been personally using Autogen from Microsoft Research, and I've been like teaching that as well. So, like, are you guys using that, or is there something different which you are using internally? And yeah, just to like tell everyone about what's cooking at Microsoft about AI agents.
Yeah, so in our team specifically, we're building the models that then the AI agents would then call and use. Okay. So we're not using the agents directly, but that's sort of the pathway, the roadmap to something that might be a commercial product, or how we tie these things together into a useful workflow that's used in pharma or materials discovery.
I've been like trying to set up a small research lab in the company. And I've been trying to like learn a lot from you and your team, and I was like reading a lot of journals from Microsoft AI Research. What advice would you give to an institution in India that want to build a world-class AI research programs today?
Yeah, I think, I mentioned it a couple times, but it's really about being multidisciplinary, bringing together scientists, researchers, engineers, and people that can think about the long-term roadmap and product. I think building open source infrastructure is always very important, but also allowing people to experiment. Experimentation is where the biggest breakthroughs come from, especially in research.
We saw a great boom in terms of people starting their own journeys and like building their own products, as compared to what initially used to happen, where people are applying for jobs and going after a more traditional route. So I've seen like personally, because we've been like training like a lot of engineers, and then we saw huge rise from engineers who now wants to like build their own products, because now the barrier to entry has like gone down, and like people can like come up with these MVPs and prototypes and go to market, right? And so we basically ended up setting up an entrepreneurship program who again uses these research and then like find the use cases, go to market, and like test the ideas whether it's like worth I can say solving for the business use case. If you have to pick, because you have seen both sides of it, you have also been involved in the pharma space as well as in the you can say research space, what are the ideas somebody can maybe potentially work on today, knowing what you know today, that can have a huge potential maybe in next 5 to 6 years? This is also for people who are now looking for ideas and maybe projects to build on in future.
Mm-hmm. I think I think the materials industry is perhaps maybe 5 or 6 years behind that of pharmaceuticals in terms of AI use and adoption. So I think there is a huge opportunity for people to get involved in that space. I mentioned that autonomous labs are something very exciting. So, something like an autonomous lab for climate-resistant materials would be something super interesting, and it's also an open market to go after. So that could be something like an AI system that designs and then simulates the properties of, then fabricates and tests new material from end to end. I think especially for a country like India, this could be really transformative. So helping to enable sustainable climate resilient materials from local resources that you have there could help the country and engineers.
That's great. I think that's really insightful. Just on a last note, I know I've been like kind of stretching it, but yeah, any advice for somebody who is basically watching this and maybe now like inspired to take the first action in terms of like learning about what you guys are doing. So any advice for them?
Yeah, like I said, I think it's about showing curiosity. So diving into the domain that you're really excited about, understanding how you can pair that with AI, and then find new ways to accelerate discovery.
Awesome. Thank you, Vani. Thank you for again taking out time and also sharing these valuable insights. It's been a great, insightful conversation. And
Yeah, thank you. Good to meet
yeah,
you.